Hey guys, welcome back to my channel. So today we're going to do paper 2 for Basic Edexcel International Advanced Level. This is paper 2, Pure Math 2 for May 2024. I've already uploaded the video for paper 1, which you can access at the link above. Let's start with this one and see how difficult or easy paper 2 was. So the first question says, find the first 4 terms in ascending powers of x of the binomial expansion of 1 minus 1 over 6x whole power 9. Giving each term in simplest form. So this is part of binomial expansion. You will expand it as 1 plus 9 times negative 1 over 6x plus 9 times 9 minus 1 over 2 factorial times negative 1 over 6x whole squared plus 9 times 9 minus 1 times 9 minus 2 over 3 factorial times negative 1 over 6x whole cube. We stop at cube because they want the first 4 terms. 1, 2, 3, 4 terms. So now we simplify it. 1 minus 3 over 2x, then plus 9 times 8 over 2 times 1 over 36 x squared, then plus 9 times 8 times 7, 3 factorial is 6, times negative 1 over 216 and then x cubed. One minus 3 over 2 x plus x squared minus 7 over 18 x cubed. This is your expansion of the given bracket, and these are the first 4 terms. Then hence find the coefficient of x cubed in the expansion of 10x plus 3 multiplied by 1 minus 1 over 6x whole power 9, giving the answer in simplest form. So you're just going to focus on the terms which will give us x cubed. So the terms which will give us x cubed are going to be x times x squared and then x cubed times the constant. So 10x plus 3 multiplied only by x squared minus 7 over 18 x cubed. We don't need to write the entire thing because our focus is just on x cubed, not on the other terms. So 10x times x squared plus 3 times negative 7 over 18 x cubed. That gives us 10x cubed minus 7 over 6x cubed, which gives us 60x cubed minus 7x cubed over 6. That's going to be 53x cubed divided by 6. So the coefficient of x cubed is 53 over 6. That's your answer. In this question, you must show all stages of reworking. Solutions relying entirely on calculator technology are not acceptable. So in arithmetic series, the 6th term is 2, and sum of the first 10 terms is negative 80. For this series, find the value of the first term and the value of the common difference. So let's start with that first. So we're going to create 2 equations. One equation is going to be for the 6th term. So T6 is going to be a plus 6 minus 1 times d. So 2, which is the 6th term, equals to a plus 5d. That is the first equation. So S10 is going to be 10 over 2 times 2a plus 10 minus 1 times d. So that's negative 80. Negative 80 equals to 5 times 2a plus 9d. 80 divided by 5 is 16. So negative 16 equals to 2a plus 9d. That is our second equation. Now we're going to solve these two simultaneously to find the value of a and d. So 2 equals to a plus 5d. Negative 16 equals to 2a plus 9d. You can use elimination or substitution method. Either will get the correct answer. I'm going to use the substitution method. And I'm going to make A the subject in the first equation. So A equals to 2 minus 5D. I'm going to substitute this equation, the second one. So sub 3 in 2. That's going to be negative 16 equals to 2 times 2 minus 5D plus 9D. Negative 16 equals to 4 minus 10D plus 9D. Negative 16 minus 4 equals to negative D. That's negative 20 equals to negative D. The negatives get cancelled out, so D equals to 20, which means A is going to be 2 minus 5D. So 2 minus 5 times 20, that's 2 minus 100, which is negative 98. That's your A value. Now in the next part, it's saying, hence find the smallest value of n for which Sn is greater than 8,000. So Sn is greater than 8,000. That's going to be n over 2 times 2 times negative 98 plus n minus 1 times d, greater than 8,000. So let's simplify this. N over 2 times negative 196 plus 20n minus 20, cross multiply. So n times 20n minus 216 greater than 16,000. 20n squared minus 216n greater than 16,000. Bring everything on one side. So 20n squared minus 216n minus 16,000 is greater than 0. I'm going to divide everything by 4 to further simplify the equation. So that's going to give us 5n squared minus 54n minus 4,000 greater than 0. We have a quadratic equation, so we're going to factorize this quadratic equation. I'm going to use the quadratic formula. So n equals to negative 54 plus minus root of negative 54 squared minus 4 times 5 times negative 4,000 divided by 2 times 5. That's going to be 54 plus minus 287.95 over 10, which is going to give us 54 plus 287.95. I'm not using the negative value because it's the number of terms. The number of terms cannot be negative, so there's no point in using that. So that's going to give us 34.195. In the question, they said that, and find the smallest value of n. So smallest value of n is going to be 35. The reason why it's 35 is because looking at the positive value, that's 34.2. Since the inequality is greater than 0, that means we look at the behavior of the x-intercept above the x-axis. Above the x-axis, this value is increasing, which means the smallest possible value of x is going to be 35, because after 35 is going to be 36, 37, 38, and so on. And they're all bigger, not the smallest. Smallest is only 35. So that's why that is your answer. Then it says, in this question, you must show all stages of breaking again. Solutions relying entirely on calculated technology are not acceptable. Using the laws of logarithms, solve 2 log 2 minus x to the base of 2 equals to 4 plus log x plus 10 to the base of 2. So as you know, for logs, we need the same bases. Over here, we have both of the logs of the same base, but we need to introduce another log, and that log is going to come with 4. So that log is going to be log 2 to the base of 2. Why? Because 4 times 1 is 4, and any log with the same base and number equal to 1. Hence, we're going to write log 2 to the base of 2. So this way, the equation stays the same, but the only difference is that we have multiplied this log with 4. Now, we know that when there is a coefficient with the log, we can take it to the bracket, like to the number, and make it the power. So it becomes log of 2 minus x whole square. Base remains the same. Over here, the 4 goes over the 2 as a power. So 2 to the power 4. And this one remains as it is. Next, what you need to remember is that whenever you have two logs with the same base being added, you can combine it as a single log and the numbers will multiply. So basically, it's going to look like this. Log and 2 to the power 4 times x plus 10. So that is going to be 2 to the power 4, 16, 16x plus 160. This is what we have. Now, next is, you can cancel out the two logs because they're the same logs on both sides. They're equal to sign. So we left with 2 minus x whole square equal to 16x plus 160. Expand the bracket. 4 minus 4x plus x squared. Then we can bring all of the terms on one side. And collect the like terms. Once you've done that, you can factorize the quadratic equation. So factors of 156 that we can use over here are 26 and 6. When we subtract them, they give us 20. So let's use those to factorize it. Factor by grouping them. And as you can see, our equation is getting factorized. X minus 26 times x plus 6. So one value of x is 26 and the other is negative 6. Then find the value of log a to the power of 6 to the base of root a, where a is a positive constant greater than 1. In this one, I'm going to use another rule of log, where we're going to split the log into log a to the power of 6 to the base of a, and then log root a to the base of a. This will help us in further simplifying the log. So we rewrite this as log of a to the power of 6 to the base of a divided by log of root a to the base of a. As we know, we can take the coefficient and make it the power, but we can also bring the power down and make it the coefficient. So it becomes 6 times log a to the base of a, and root is the power of 1 over 2, so 1 over 2 times log a to the base of a. Both the logs are same, so they get cancelled out, and we have 6 divided by 1 over 2, which is 12. So that's your answer. Then it says f of x equals to x minus 2 times 2x squared plus 5x plus k plus 21, where k is a constant. State the remainder when f of x is divided by x minus 2. So for that, we put x equals to 2 in the equation and see what we get. That's going to be 2 minus 2 times 2 squared plus 5 times 2 plus k plus 21. 2 minus 2 is 0. 0 multiplied by the entire bracket is also going to be 0. So 0 plus 21 and the remainder is 21. Then given that 2x minus 1 is a factor of f of x, show that k equals to 11. So if it's a factor, that means f of x will equal to 0 when you substitute x equals to 1 over 2 in the function. So f of 1 over 2 equals to 1 over 2 minus 2 times 2 times 1 over 2 squared plus 5 times 1 over 2 plus k plus 21. 0 equals to negative 3 over 2 times 1 over 2 plus 5 over 2 plus k plus 21. Negative 21 equals to negative 3 over 4, expanding the bracket, negative 15 over 4 minus 3k over 2. That's negative 21 equals to negative 18 over 4 minus 3k over 2. Take the negative 18 over 4 to the other side. It becomes plus 18 over 4. So that's going to be negative 84 plus 18 over 4, which is, that's going to be negative 33 over 2, cross multiply 2 divided by negative 3 equals to k. That's going to be 11. So 11 equals to k. Then in part C, they're saying that hence fully factorize f of x and find the number of real solutions of the equation f of x equals to 0, giving a reason for your answer. So the function firstly is going to be x minus 2 times 2x squared plus 5x plus 11 plus 21. Let's expand the bracket. So 2x cubed plus 5x squared plus 11x minus 4x squared minus 10x minus 22 plus 21. 2x cubed plus x squared plus x minus 1. Now we have to factorize this. We already know that 2x minus 1 is a factor which is mentioned in the question. So we're going to use division to factorize this polynomial. So 2x times x squared is 2x cubed. X squared times negative 1 is negative x squared. Change the sign again. So that's going to be 2x squared plus x minus 1 comes down as it is. Then 2x times x is going to be 2x squared. Change the sign. X times negative 1 is negative x. Change the sign. That's 2x minus 1 times plus 1. So that's going to be 2x. It's positive. Make it negative. That's 0. Negative, you make it positive. That's 0. So it's 2x minus 1 times x squared plus x plus 1. That is your fully factorized form. Then, in the second part, it was saying that hence find the number of real solutions to the equation f of x equals to 0. So f of x equals to 0. F of x was 2x minus 1 times x squared plus x plus 1 equals to 0. So now we need to factorize the quadratic equation to see if there are any real solutions. So x equals to -1 plus minus root of 1 squared minus 4 times 1 times 1. We can clearly see that it's going to be -3 inside the root. And we know root of a negative number is not possible because it's going to be an imaginary root over here, not a real root. So since it's root of -3, no real roots. That's the reason. If it was positive root, there would be real roots. Hence, the only real root is x equals to 1 over 2 is the only real root. That's your answer. Then given that x and y are positive numbers such that x minus y to the power of 3 is greater than x cubed minus y cubed, prove that y is greater than x. So for this, we're going to use, we're going to first expand x minus y whole cube, and for that you can use one of the cubic expansion identities, x cubed minus 3x squared y plus 3xy squared minus y cubed is greater than x cubed minus y cubed. X cubed minus x cubed is going to be 0. Negative y cubed plus y cubed is going to be 0. So we have negative 3x squared y plus 3x y 3xy squared greater than 0. 3xy squared is greater than 3x squared y. 3 divided by 3 is 0. There's going to be y over here because y squared divided by y is y, and x squared divided by x is x. So y is greater than x as given in the question. Using a counterexample, show that the result in part A is not true for all real numbers. So for that, let's assume that x is 3 and y is -1. Counterexample is going to be the opposite thing. So in part A, they're saying y is greater than x. We're proposing the opposite, that x is bigger than y. So let's say x is 3 and y is -1. So we put in the equation, which was x minus y whole cube is greater than x cube minus y cube. So when you put this over here, 3 minus -1 cube is greater than 3 cube minus -1 cube. 3 minus -1 is 3 plus 1, which is 4. So 4 cube is greater than 27 plus 1. 4 cube is 64. 64 is greater than 28. So it is true. So what the question was suggesting was that show that the resultant part is not true for all real numbers. And that's true. It is not true for all real numbers. Then sketch the curve with equation y equals to a to the power of x plus 4, where is a positive constant greater than 1. On your sketch, show the coordinates of the point of intersection of the curve with the y-axis, the equation of the asymptote of the curve. So for that, the equation is y equals to a to the power of x plus 4. A to the power of x is this. The y-intercept is 1 and x-axis is the asymptote. So when you're shifting it 4 units up, your intercept becomes 5 because you're adding 4. And your asymptote is going to be y equals to 4. This is your asymptote. And this is your y-intercept. There's going to be no x-intercept because the graph is above the x-axis. Then the table shows corresponding values of x and y for y equals to 2 to the power of x minus 2x, with the values of y given to 4 decimal places as appropriate. Using the trapezium rule with the values of y in the given table, obtain an estimate for the integral of 2 to the power of x minus 2x dx for values from 2 to 3.5, giving your answer to 2 decimal places. So for the trapezium rule, let me label that part A. Okay, so we know that it's going to be h over 2 times y naught plus yn plus y1 plus y2 plus y3 and so on till yn minus 1. This is your formula. So h is going to be the difference of two consecutive x values. So we can do 2.3 minus 2 over 2. It's going to be the first value, which is 0, and yn is going to be the last value, which is 0.43137. And to this, we're going to do 2 times, but the 2 over here, it's 2 times this. So 2 times 0.3246 plus 0.8629 plus 1.6643 plus 2.7896. Put this in the calculator and what you get is 2.34. That's your answer. Then it's saying, using your answer to part B and making your method clear, estimate the integral of 2 to the power of x plus 2x dx and 2 to the power of x plus 1 minus 4x dx, and the limits are the same. So for the first one, from 2 to 3.5, and it's 2 to the power of x plus 2x dx. So what we can do is we can rewrite 2x as 4x minus 2x. This will help us in going back to the equation given the question, which is 2 to the power of x minus 2x. So 2 to the power of x minus 2x plus 4x. What we will do now is we will split this into two parts. One part is going to be the integral of 2 to the power of x minus 2x dx from 2 to 3.5, and the other is going to be the integral of 4x with the same limit. So now, the first part will have the same value which we found in the previous part, which is 2.34. And the integral of 4x is going to be 4x squared over 2. And put in the limit of 2 and 3.5. So that's going to be 2 times 3.5 squared minus 2 times 2 squared. That's 16.5 added up, which gives us 18.84. Then the integral of 2 to the power of x plus 1 minus 4x. So you can split this into 2 to the power of x times 2. minus 4x dx. Now we know between 2x and 4x we have 2 common. So the 2 comes outside. Inside over here we have 2 to the power of x minus 2x, same as the original thing. So again we just replace it by 2.34. Then we times that by 2, and that's going to be 4.68. That's your answer. So for these type of questions, you need to know how to rearrange your equation to make it in the same format as the original equation so that you can use your estimated area from the previous part. That's always going to be the case with these type of questions. Then the circle C1 has equation x squared plus y squared equals x squared plus y squared plus 8x minus 10y equals 29. You have to find the coordinates of the center and the exact values of radius for the circle. So to do that, what we will do is we'll use completing square form to convert this into the format which gives us the center coordinates and the radius. So let's rewrite this as x squared plus 8x plus y squared minus 10y equals to 29. We will use completing square form on this and this separately. So to complete the square for x squared plus 8x, we're going to add 4 squared and then minus 4 squared. For y squared minus 10y, we're going to add 5 squared and minus 5 squared. So that's going to be x plus 4 whole square minus 16 plus y minus 5 whole square minus 25. So x plus 4 whole square plus y minus 5 whole square equals to 29 plus 25 plus 16. That's going to give us x plus 4 whole square plus y minus 5 whole square equals to 70. So your coordinates of the center are -4 and 5. And your radius is going to be root of 70. By now you must know that the circle of an equation is x minus h whole square plus y minus k whole square equals to r square. So radius is going to be root of 70 and h and k are your coordinates of the center. So if it's not minus over here, if it's plus, you add a minus sign with the number. Then it says that in part B you must show detailed reasoning. The circle C2 has equation x minus 5 whole square plus y plus 8 whole square equals to 52. Prove that the circles C1 and C2 neither touch nor intersect. So for that, there can be two ways. If they're intersecting over here at the boundaries. So this is R1, this is R2, C1, C2. This is one form of intersection we can get, or we can say that their centers are overlapping. So center over here, center over here. So the radiuses are overlapping basically over here. We're proposing two scenarios. So based on these two scenarios, in one case, we're adding up the radiuses. That's going to give us the total distance over here. And the other scenario, what we're doing is we're finding the distance between the centers. Because over here, both the circles are lying on each other's centers. So we know that radius of C1 is root 70. Radius of C2 is going to be, based on the question, root 52. So sum of radius is going to be root 70 plus root 52, and that equals 15.58. Now we're going to use the centers to find the distance between the two centers. So distance between centers. So that's going to be -8 minus 5 whole square plus 5 plus 4 whole square. That's going to be 13 squared plus 9 squared, and that's 15.81. Now, if we think about this logically, the distance between the two radius is given as 15.58 based on our calculation. And over here, when the circles are overlapping each other and they're both present on the centers of each other, so that distance is given as, that distance is calculated as 15.81. That distance, based on the values, is more than over here when the distance is greater between the two centers of the circles. So that makes no sense. Like this distance, the distance between the two centers over here when they were not overlapping, that distance should have been greater compared to the one where they were overlapping, which means the circles were never intersecting, because if they were intersecting, it would be the opposite. In the first case, the distance would be greater than the distance in the second case. So since sum of since sum of radius is greater less than the distance between the centers, they do not intersect. Then solve for x from 0 to pi, the equation 5 sine x times tan x plus 13 equals to cos x. Give the answer in radians to 3 significant figures. So for this, let's begin with rewriting the tan x as sine x over cos x plus 13 equals to cos x. Multiply the sine x, so 5 sine square x over cos plus 13 equals to cos x. Multiply all of the terms with cos x, so 5 sine square x plus 13 cos x equals to cos square x. In order for us to fully solve this equation, we need to convert all of them into cos square x, which means sine square x will be replaced by 1 minus cos square x. So that's going to be 5 minus 5 cos square x plus 13 cos x equal to cos square x. Bring everything on the right-hand side. So that's going to be 6 cos square x minus 13 cos x minus 5. Now we're going to factorize this quadratic equation. 6 times 5 is 30, and the factors of 30 that we can use over here to replace 13 is 15 and 2. So 0 equals to 6 cos square x minus 15 cos x plus 2 cos x minus 5. In the first two terms, we have 3 cos x common. So 2 cos x minus 5 in the bracket. The last two terms we have one common, so 2 cos x minus 5 in the bracket. So that's going to be 2 cos x minus 5 bracket 3 cos x plus 1, which means cos x equals to 5 over 2 and cos x equals to negative 1 over 3. So over here it's going to be cos inverse of 5 over 2, which gives us a value of not applicable because cos cannot be greater than 1, and this is going to be cos x equals to 2.5. Hence over here cos inverse of negative 1 over 3, that gives us 1.91. So 1.91 radians is your angle correct to 3 significant figures. Then it says the temperature inside a greenhouse is monitored on one particular day. The temperature H degrees Celsius inside the greenhouse T hours after midnight is modeled by the equation H equals to 10 plus 12 times sine KT plus 18, where T is between 0 to 24 and K is a constant. Use the equation of the model to answer parts A to C. Given that the temperature inside the greenhouse was 20 degrees Celsius at 6 a.m. K is between 0 to 20. Find all possible values of K, giving each answer correct to 2 decimal places. So we have the value of H and T. We're going to put that in the given equation. To find the value of K. H equals to 10 plus 12 sine of K times T plus 18. So that's 20 equals to 10 plus 12 times sine of K times 6 plus 18. 10 equals to 12 sine of 6K plus 18. 10 over 12 equals to sine of 6K plus 18. Then we take sine inverse of 10 over 12, which is going to give us a value of 56.44. Sine is positive in the second quadrant as well, so we're going to minus this from 180, which gives us another angle, which is 123.56. So K is going to be 56.4 minus 18 divided by 6. Same over here, 123.56 minus 18 divided by 6. That gives us two values, 6.41 and 17.59. Then given further that K is between 0 and 10, find the maximum temperature inside the greenhouse. So if it's between 0 and 10, that means K is going to be 6.4. And the equation is going to be H equals to 10 plus 12 sine of 6.41 T plus 18. Maximum temperature means this entire thing equals to 1 because the maximum value of sine is 1. That equals to 22 degrees Celsius. Then find the time of the day at which this maximum temperature occurs, giving your answer to the nearest minute. For this, 22 equals to 10 plus 12 sine of 6.41 T plus 18. 22 minus 10 divided by 12 equals to sine of 6.41t plus 18. That's 1 equals to sine of 6.41t plus 18, or you could even directly put sine 6.41t plus 18 equal to 1. I was talking about the maximum value. So sine inverse of 1 gives us 90. 90 minus 18 divided by 6.41. That gives us 11.23 as t. Now convert the 0.23 into minutes, which is going to be 13.8 minutes. So that's 14 minutes. The reason why I'm writing 14 minutes is because in the question it said that give your answer correct to the nearest minute. So 11 hours and 0.23 hours are converted into minutes, which is 14 minutes. So it's 11:14, or you can say 11 hours and 14 minutes. That's your answer. Then it says figure 1 is a sketch of the curve C with equation y equals to 2x to the power of 3 over 2 times 4 minus x, where x is greater than or equal to 0. The point P is the stationary point of C. Find using calculus the x coordinate of P. So to find the x coordinate of P, we know that P is the stationary point on C, which means we differentiate the curve, put it equal to 0, and then find the x coordinate for P. So y equals 2 times x to the power of 3 over 2 times 4 minus x. We can expand the bracket to simplify the equation. That's going to be 8x to the power of 3 over 2 minus 2x to the power of 3 over 2 plus 1. When similar bases are being multiplied, we add the powers. So that's going to be minus 2x to the power of 5 over 2. Now we differentiate this. Bring the power down, subtract 1 from the power, so 3 over 2 times 8 times 8 times x to the power of 3 over 2 minus 1 minus 2 times 5 over 2 times x to the power of 5 over 2 minus 1. That's going to be 12x to the power of 1 over 2 minus 5x to the power of 3 over 2. Put dy by dx equal to 0, and now let's find the value of x. So 5x to the power of 3 over 2 equals to 12x to the power of 1 over 2. X to the power of 3 over 2 divided by x to the power of 1 over 2 equals to 12 divided by 5, which is going to be x equals to 12 over 5. That is the x coordinate of point C, point P. Then says the region R1 shown here in figure 1 is bounded by C and the x-axis. Region R2 also shown here in figure 1 is bounded by C and the x-axis and the line with equation x equals to k, where k is a constant. Given that the area of R1 is equal to the area of R2, find using calculus the exact value of k. So we know when we're trying to find the area under the graph, we're going to use integration. So let's first find R1. So we know y equals to 8x to the power of 3 over 2 minus 2 times x to the power of 5 over 2. If you notice, in the graph, they haven't given us the point at which the graph is crossing the x-axis, which means to find the x-intercept, we have to put y equal to 0 first. Because without the limit, we can't integrate it. So 0 equals to 8x to the power of 3 over 2 minus 2x to the power of 5 over 2. 2x to the power of 5 over 2 equals to 8x to the power of 3 over 2. That's going to be x to the power of 5 over 2 divided by x to the power of 3 over 2 equals to 8 over 2. That's x equals to 4. So for R1, your lower limit is 0 and upper limit is 4. Let's integrate it now. So it's 8x to the power of 3 over 2 minus 2x to the power of 5 over 2 dx. Add 1 to the power, divide the term by the new power. So 8x to the power of 3 over 2 plus 1 divided by 3 over 2 plus 1 minus 2x to the power of 5 over 2 plus 1 over 5 over 2 plus 1. This is from 0 to 4. Let's simplify this. So that's going to be 16 over 5 times x to the power of 5 over 2 minus 4 over 7 times x to the power of 3 over 2. Now we put in the limits, 4 first and then 0. There's no point in putting 0 because it's going to give us 0. So 16 over 3 times 4 to the power of 5 over 2 minus 4 over 7 times 4 to the power of 3 over 2. Sorry, that's 7 over 2, not 3 over 2. That was 5. Yeah. 7 over 2 and 7 over 2. So that gives us a value of 512 over 5 minus 512 over 7, which simplifies to 1024 over 35. That is the area of R1. Now for area of R2, we can see that we're talking about the part of the curve that's underneath the x-axis. So that means the area is going to be considered negative over there. So it's going to be negative of the equation, basically. Any part above the x-axis is positive, underneath the x-axis is negative. So using that concept, we're going to rewrite the equation as for region 2. So since for R2, I said that it's underneath the x-axis, so that's going to be negative. So R2 is going to be minus integral from 4 to k. Lower limit is 4 and upper limit is k. And this is 8x to the power of 3 over 2 minus 2x to the power of 5 over 2 dx. We know integral is the same, which is 16 over 5 x to the power of 5 over 2 minus 4 over 7 times x to the power of 7 over 2 from 4 to k with negative sign outside. So you put in the value of 4 and k, so with k it's going to be 16 over 5 x to the power of 5 over 2 minus 4 over 7 x to the power of 7 over 2 minus, and then we have the value 1024 over 35. We already know what is the value when you put x equals to 4 in the integral. So this said that R1 is equal to R2. R1 is 1024 over 35. R2 is 16 over 5 minus 16 over 5 x to the power of 5 over 2 plus 4 over 7 x to the power of 7 over 2 plus 1024 over 35. When we take the 1024 over 35 to the other side, we minus them and it becomes 0 on the side. This remains the same over here for now. And over here, this should be k. This is k now because the lower limit was 4, upper limit was k. So k to the power of 5 over 2 plus 4, 7, k to the power of 7 over 2. Okay, so that's 0 over here. Now we have to find the value of k. So for that, 16 over 5 times k to the power of 5 over 2 equals to 4 over 7 times k to the power of 7 over 2. Collect the variables on one side and the numbers on the other. So I'm going to do 16 times 7 over 5 times 4 equals to k to the power of 7 over 2 divided by k to the power of 5 over 2. So that's going to be 28 over 5. K to the power of 7 over 2 divided by k to the power of 5 over 2 is k. So this is your value of k. Then says the number of dormice and the number of voles on an island are being monitored. Initially, there are 2,000 dormice on the island. A model predicts that the number of dormice will increase by 3% each year. That the number of dormice on the island at the end of each year forms a geometric sequence. Find, according to the model, the number of dormice on the island 6 years after monitoring began, giving your answer correct to 3 significant figures. So we have the initial value, which is 2,000. We know by how much it's increasing. So we're going to create a geometric equation. So UN, our nth term, is going to be 2,000, which is our initial value, times 1.03, which is our rate, to the power of n. So we have to find the sixth term, which is going to be 2,000 times 1.03 to the power of 6, and that equals to 2,390. That's your answer. Then says the number of voles on the island is being monitored over the same period of time. Given that 4 years after monitoring began, there were 3,690 voles on the island. 7 years after monitoring began, there are 3,470 voles on the island. The number of voles on the island at the end of each year is modeled as a geometric sequence. Find the equation of this model in the form of n equals to a times b to the power of t, where n is the number of voles, t years after monitoring began, and a and b are constants. Give the value of a and the value of b correct to 2 significant figures. So what we'll do is we'll use the same method. So for 4 years, it's 3,690 equals to a times b to the power of 4, because t is 4 and n is 3,690. The other equation is going to be 3,470 equals to a times b to the power of 7. So let's use this to find the value of a first. So if we make a the subject in the first equation, 3,690 divided by b to the power of 4 equals to a. So 3,470 equals to 3,690 divided by b to the power of 4 times b to the power of 7. That's 3,470 divided by 3,690 equals to b cube. So 0.94 is equal to b cube. Cube root both sides. And that gives us a value of 0.979 as b. Round that up. So two significant figures, that's going to be 0.98. That's B. Then for A, it's going to be 3,690 divided by 0.98 to the power of 4. And that gives us a value of 4,000.57. We need to correct to two significant figures. That's going to be 4,000. So now to make the equation, it's going to be n equals to 4,000 times 0.98 to the power of t. That's your equation for the model. Then in the next part, they're asking that when t equals to capital T, the number of dormice on the island is equal to the number of voles on the island. Find, according to the models, the value of capital T, giving your answer to one decimal place. So if they're both equal at that point, we put both the equations equal to each other, the first equation and the new one as well, and that will help us in determining the value of T. So that's going to be 4,000 times 0.98 to the power of capital T is for the voles, and for the dormice, 2,000 times 1.03 to the power of T. So 4,000 divided by 2,000 equals to 1.03 to the power of T divided by 0.98 to the power of T. That's 2 equals to 1.051 to the power of T. I divided both 1.09 by 0.98. And now, wait, this needs to be power. This doesn't look like power. To the power of T. So now I put logs on both sides so that we can bring the variable down. So log of 2 equals to log of 1.051, and T is over here. So last step, T is going to be log of 2 divided by log of 1.051, and that gives us a value of 13.9, correct to one decimal place. That is your number of years, and with that, we're done with this paper. If you have any questions or confusions, please leave a comment below and I'll help you out. And if you understood everything, please like and subscribe and share this video with your friends.